So hello everyone, my name is Ganesh Miratskar. Today we are going to discuss about the multiple choice questions from the chapter Rotational Dynamics from the book Target. First question, angular displacement in circular motion, is it having unit? Radian is the unit and it is dimensionless quantity. So answer of the first question is B, dimensionless quantity. Next, direction of angular acceleration and radius vector, what is that? This is angular acceleration and radius vector cross product is always along the tangential direction, so it will give linear acceleration, so tangent to path. Next, vector relation between linear velocity and radius vector, this is standard expression, v is equal to omega cross r, where v is the linear velocity, omega again direction is axial, and radius vector is this, so cross product will give you linear velocity. Next, angular speed of seconds hand of the watch. Okay, what is the formula? Let me clear it, clear the scale. Okay, omega is equal to 2 pi upon t, t is 60, so here we can write 60, so 230, so pi by 30 is the answer. Option C is the correct answer. Okay, so clear the screen. Question number 5. So what is that? Angular velocity of the earth, again 2 pi upon t, and for earth value of t will be 24 into 60 into 60, so it comes out to be 86400. So option A is the correct answer. Let me clear the screen. Next question, ratio of angular speed of minute hand and hour hand of the watch. We know that omega is inversely proportional to t, so here we can say that ratio directly we can calculate 12 into 60 by 60 divided by 60 multiplied by 60, so 12 is to 1. Option D is the correct answer. Clear the screen. So for sixth question, option D is the correct answer. Next, angular velocity of particle rotating the orbit 100 times per minute. What they have asked, angular velocity. So omega is equal to 2 pi f, 2 pi, frequency is given as 100 per minute, so this comes out to be 2 3s are, so near about 3.14 into 10 is 31, 3.4 divided by 3, so it comes out to be 10 point, near about 10.47. Option B is the correct answer. So clear the screen. Okay, question number 8, what they have asked, body of mass 100 gram is revolving in horizontal circle, frequency of 3.5 rotation per second, radius of circular path is 0.5 meter, the angular speed of the body, again omega equal to 2 pi f, frequency is given as 3.5. okay, then angular speed what they have asked. Okay, 3.5 into 2 is 7 pi, so it comes out to be 3.14 into 7 approximately comes out to be 22. Ninth question, let me clear it, the screen. Okay, electric motor of 12 horsepower generates angular velocity 125 radian per second. What will be the frequency? Here in this way, this is not required. 12 horsepower power value is not required. What will be the frequency? Again, omega is given 125 is equal to 2 pi f. Frequency f is to be calculated. 125 is equal to 2 into 3.14, approximately 6.28. okay, and 125 divided by 6.28, 6 2s are 12, so approximately the value is 20. Okay, 125 divided by 6.28, 6.28 is from 2 pi. Okay, so option B is the correct answer. So clear the screen. Question number 10. Body moves with constant angular velocity, okay, on circle. Magnitude of angular acceleration. आता the angular acceleration is asked and constant angular velocity. We know that angular acceleration is d omega upon dt. So constant term, derivation of constant term is always 0. So B is the correct answer. 11. Calculate angular acceleration of centrifuge which is accelerated from rest to 350 rotation per second in 220 second. How to calculate? Alpha is omega minus omega naught upon t. So omega we know that it is 2 pi f. So alpha is equal to 2 pi times f minus f naught divided by t. 2 pi 2 into 3.14, f naught is 0. So 2 pi multiplied by 350. So 2 into 3.14 multiplied by 350 divided by t. The value of t is given as 220 seconds. Let's calculate this. So it comes out to be 6.20, so 6.28. 6.28. 6.28. 35 into, let us suppose 6.28 divided by 22. So approximately it comes out to be 10 radian per second. Once you calculate, let me clear it. Next, a wheel has circumference c. If it makes f rotation per second, the linear speed of point on the circumference is, okay, v is equal to r omega is equal to r into 2 pi f. We know that circumference c is equal to 2 pi r. So r is c upon 2 pi. So c upon 2 pi into 2 pi f. So 2 pi cancels. So c into f. So option B is correct answer. Let me clear. Okay. Question number 13. A body is whirled in horizontal circle of radius 20 cm. It has angular velocity 10 radian per second. What is the linear velocity? What is the formula? We know that v is equal to r omega. So r is 0.2. Omega is given as 10. What is the value? 2 meter per second. Option B is the correct answer. Okay, so clear it. In uniform circular motion, option A is both velocity acceleration are constant. This is wrong. Velocity changes and acceleration is constant. This is also wrong. Velocity is constant and acceleration changes is also wrong. Velocity is changing and acceleration is also changing. Acceleration at every point, okay, and velocity at every point, the direction is also changing. So option D is the correct answer. I think this question is asked with one of the previous year questions. in CET. Next, question number 15. Particle performing uniform circular motion has radial velocity, radial acceleration, radial velocity, transverse acceleration, transverse velocity, and radial acceleration. Correct. Transverse velocity. Transverse velocity means, okay, transverse velocity. This is the radius. This is the radius, and this is the transverse velocity. And acceleration, radial acceleration is towards center. So transverse velocity and radial acceleration, that is the correct answer. Option C is the correct answer. Question number 16. What they have asked is, in circular motion, centripetal and centrifugal forces are in opposite direction, balance each other. What should be the answer? Centripetal and centrifugal force don't act at the same time. These are two statements. Centripetal, okay, we know that centrifugal force is pseudo force and it is only for non-inertial. So we can say that this is wrong, assertion is wrong. And centripetal and centrifugal force don't act at same time. Okay, it is the question of the frame of reference. It is imaginary force. Pseudo force, you can say, centrifugal force is pseudo force. It is not real. So it is only valid for non-inertial frame. So this reason is correct. So option D is the correct. Let me clear the screen. And question number 17. 17 says, when a body moves with constant speed along the circle, what is linear velocity remains on a work? Okay, constant speed, and we can say force is along the center, and this is the velocity or displacement. So angle between displacement and force is 90 degree. So work done is 0. So no work is done on it. That is the answer. Clear the screen. Question number 17 we have completed. So we will stop over here because of the less time. Still we will try to cover some 2-3 problems. Okay. 18. In uniform circular motion, correct, both angular velocity and angular momentum remains constant because angular momentum L is equal to I omega. Omega is same and I is also same for uniform circular motion. So for 18, option C is the correct answer. So we'll stop over here because of less time.